Hey there.
Hello.
Okay, let's wait for, let's say, 3 minutes. Sorry about my lighting. I'm like sunny here in LA. um, but let me see if I can check my screen. Cool. Everybody should see this.
Yeah, I see that.
Cool. So in the meantime, just go to the GitHub data science course and go to week 9. So should go to week 9. Let me see if I can take this guy out. Is there any way I can take this out? Like, I'm just gonna put it down here. See what happens. Okay. So, how's everybody doing?
All right. Trying to survive.
Isolation break. I mean, spring break.
Yeah, well, not much of a break. I had an exam right after, so
I feel same. Actually, well, not exam. It got canceled. Like, thank God. But it's an assignment.
lucky.
Yeah. It is what it is. Like I wish we had the option to, like this might not be popular, even though this is recording, but I wish you had the option to like suspend the semester, and continue later. Like, but I know some people want to graduate or so,
Yeah, this is my last semester, so
yeah.
honestly, like if I can still take my classes, I would do it.
I feel, yeah, that's what I'm saying. It's like, some people prefer one way, some people prefer a different way.
Yeah.
If it was to be my last semester, yeah, I would totally like I would totally get you. Like, but yeah, it's unfortunate, but life still, well, hopefully life still goes on. It will.
Yeah, definitely. I mean, I feel like if they had said there's no way for us to do this, we have to suspend the semester, I wouldn't have felt that bad about it. But the fact that we can do it, I'm like, okay, I'm all for it.
I feel, yeah, it is what it is, But let's start. So let's get started. Let me see how many people are. We have 6 people here, 7 people, so it's increasing. Okay, so yeah. In the meantime, go to week 9. Um, so make sure you have a Kaggle account. It will, if you don't have one by now, um, make sure you go to Kaggle. Um, let me see. Oh yeah, Kaggle is doing a competition for COVID-19. There's a lot of people there's prizes, there's money prizes there too. You guys are interested. You can take that as your project too. Um, I mean, doesn't mean you're gonna cure it, but you can do some analysis. Like there's multiple types of data sets. Actually, I was looking at that. There's the sequence DNA, so you can study that in DNA level. There's the proteins as well, so you can do. Actually, in the protein level, I wouldn't really touch it unless you know how to use tools like OpenMM, which is for molecular dynamic simulations. Um, there's some things that you can do with neural networks, but that's kind of advanced. I would, if you decide to do your project on COVID-19, I would suggest to do it with data that's more, I would say, on the population base, not on the chemical or not on the DNA base. So reason why is because that going like studying genomes and things like that, it's kind of hard, and those are things that we're not teaching you. Well, we're not teaching you in this class, but on the population level, whatnot, that's something that could be doable. You can make a bunch of histograms. You can make up a bunch of plots, and you can clean the data using pandas, and those things could help you a lot, right? So today, what we will do, we'll cover a few things. So we will use the data set from Kaggle. I will show you how to connect your notebook from Colab to Kaggle, but for that you need an account. And I will show you how to download a data set from Kaggle to your Colab. Um, So make sure you are registered in Kaggle. So make sure you're registered in Kaggle. It's really easy, actually. You don't need to put anything. I actually registered just using my Google account. So yeah. So let me see. Put in the chat if you have Kaggle. We'll do it at the end of the class, either way. Not at the end, in the middle of the class, we'll I guess work with a data set from Kaggle. And let me show you the data set we're working with. We're working with cats. Oh.
Sí, ahorita ya. Pero ahorita ya estaba aplastada a dos nalgas ahí.
Okay, make sure your thing is muted. It's fine. I may actually have my mom or something coming in because I'm in the living room. Anyways, so yeah, we're gonna be working with this data set. It's a really popular data set to get started with. It's really easy to follow. It's the cats versus dogs. So it's a bunch of images. It's a bunch of images, cats and dogs. Okay, so a little recap we should actually get started. We have, how much people we have here? We have 9 people. Okay, that's good enough. So let's see. So last time we did linear logistic regression and everything on Pytorch. Then again, these are libraries that let you do all of these derivatives, all of these optimizations for you. So all that you need to worry about is building your model, and 2, just feeding in the data and doing that in the right way. The right way is just pretty much making sure the shapes are right, making sure you keep a flow with your data, and so on. So last time, what I showed is that on logistic, I pretty much mentioned that logistic regression is the type of neural network. So pretty much you have 10 neurons, and each of the neurons would throw 1. So for example, if we pass a bunch of numbers and we see a 0, right? The neuron that has that neuron will throw a 1, and the other ones will throw 0. And the other ones, and if you pass, say, a 2, number 2, this neuron would actually be 1, and the other ones would be 0. So it's pretty much like a neuron gets activated. So this right here, what you're looking at is that if you are to get the weights or the numbers, like all the vector from the neuron, and you are to visualize it, it actually looks like the numbers. Like you see 0, 1, 2, 3, 4, 5. Well, this one kind of looks like a 5 a little bit. 6, 7, 8, 9, right? Does this kind of look like numbers for you guys?
Yeah, kind of.
Yeah. So so on logistic regression, so you only have one layer, right? And last time we talked about that in deep learning, you have multiple layers. What that means is that you're gonna get your logistic regression, and the outputs of that, you're gonna pass it to another logistic regression, and you can keep doing that. And why do you do that? So you can get non-linear. It's pretty much it says that it's non-linear understanding of the data. What does that mean? For example, let's say that. Okay, for example, number 9. It's kind of weird here, right? But number 9, what is number 9 composed of? Number 9 is composed of a little circle and a little, like, I don't know how to say this. Well, it's basically, if you put this 0 and this 1 together, it will be a 9, right?
Right.
And if you, for example, an 8 has 2 circles, right? So you have a circle down and a circle up here. And let's say that a 4 is made of a 1 plus this little triangle on the top, and some things like that, right? So we can, like, say, decompose the data in smaller portions. So hopefully the first neurons would get that. The first neurons from your neural network would learn those patterns, and then later on the network, we will start unifying those patterns. For example, if you see a circle and then a 1, then you're gonna be, okay, that's a 9. But if you see 2 circles, then you're gonna be, okay, that's an 8, right? But you can only do that if you have deeper weights. So pretty much on the first stage of your neural network, you will pretty much, the first stage, it's sort of like a feature structure. And the later stages are pretty much mixing the features together. So pretty much, if you, for example, let's go to so last time I did a neural network. It's like a small neural network. This is on week 8 on the last part. We didn't have time to go over that. This is sort of like what the first layer sees. It's a bunch of, this is a 1. So it sees some patterns that for us, it doesn't make sense, right? On an idealistic way, they should have a 1. Another one should have like a little circle here, a little circle here, idealistically, but it doesn't. Why? Because these models are thought to be like black box models. So they can approximate any function, and having an intuition of why is it doing that, or if you were to visualize the weight, kind of like we're doing here, a lot of times they do not make sense. They don't make sense, but they end up working. They end up doing what you want them to do. In this case, it's for the task of prediction. You want to predict a number. What are these neural networks used for a lot, right? So why are we bothering learning these things? For one thing is that, what if I was to ask you, like, make me a program or make me something that recognizes cars and recognizes people and recognizes objects, right? What features do people, what features do cars, what features do certain objects have in common, and what features do they differ? What features are they different by, right? And if you were to think manually, you were to think by yourself, what features would make sense, it probably would take you forever, right? Because some people at the beginning, like 20 years ago or whatnot, they would take these guys and would like make the features by themselves. And sure, they will work, right? But when you get to deeper tasks, right now, Google and Tesla, they're building their self-driving cars, right? And getting those features is hard, because what things come up when you're driving, right? Like someone might go in front of you, you might have a bicycle in front of you, or you might be going backwards. How can you tell that to the computer? So the only answer to that is more data. And 2 is that the neural network, it's doing all these non-linear transformations on the deeper side. So it's pretty much getting a deep understanding of the data. And it works like a black box, because we cannot know what's going on inside. And that's why a lot of people hate them and a lot of people love them. A lot of people hate him because these models cannot really be explained. At some point, people treat them like black boxes. And a lot of people hate him also because sometimes they want to use them for, so say that you're working with a data set like the cats versus dogs, or you're working with genomes, or you're working with, I don't know, you're working with astronomical data, and you're like, you know what, I'm gonna be using a neural network, right? The problem with that is that using a neural network should not be your first answer, should not be your first option to do it. You should first try the things that we learn in the class. You should first try, okay, do I want to classify the data? If I want to classify it, I should use logistic regression, just plain logistic regression. If I want to predict numbers, say I want to do a prediction of house prices, I want to do a prediction of how is this disease going to, what is the number of people that are going to be infected in like later stages, right? Then you should be using a linear regression, because the linear regression assumes it's going to predict a number, right? You should not go straight to neural networks. That's what I'm trying to say. Use neural networks when your models, when the data that you're looking at is not structured. What I mean by not structured is that you don't know what kind of features you're looking for, and you don't know like, and also you want to use neural networks when no other model that you know works. Okay, so having that said, let's get started. So make sure you have your Kaggle account. Also go to data science course week 9, and open in Colab. let's do that. Make sure you're here. Everybody here?
Yes.
Cool.
Yeah.
Awesome. Okay, so today we'll be using so we'll be doing some neural networks, and at this point, don't really worry how much they work, or how they exactly work, because just take into account that a neural network is a complicated model. We're just stacking a logistic regression in top of a logistic regression or whatnot. Just take into account that Pytorch, it's doing all those gradient descents for you. So at this point, you're not worrying about that. But what you're worrying about now is how you're going to load your data, and how you're going to look at your results, and you also want to worry about the presentation of them. And so those are things that so after today's class, you should be ready to get started on your project. Yeah, so you should be totally ready to get started on your project. I highly encourage you to use datasets from Kaggle, and I will show you how to do that too. So let's get started. So the first part, just run these libraries. So this number was not authorized by Google. Okay, cool. So let's run that. TensorFlow backend. Okay, cool. Okay, I forgot to mention one thing. So everybody go to runtime. Okay. Then go to change runtime type. Make sure you're here. So go to runtime, change runtime type, and when you do, so you're gonna have the option of Python 3, Python 2. Don't use Python 2 because Python 2 it's already lost support. So Python 3 is very much Python is forcing you to use Python 3. Then hardware accelerator. So on the other classes, we were not using any hardware accelerator, but for this class, we will use GPU, and I'll explain why. Okay. So make sure you have GPU right there, and put save. Once you have that, you should run this thing, and it should be fine. So everybody did that. Make sure your GPU is selected. That's really important.
Yeah, I got that.
Okay, so okay, so I could make the class go. I mean, at the beginning we installed Jupyter and all these things in your computer, but then later we were using Colab, right? And then why did I do that, right? Why are we using Colab? One is because Colab can be accessed by everybody, and not everybody got the chance to install it in their computer. Two, it's because a lot like these topics right here require a lot of computing power, and a lot of your laptops like mine would not be able to do that kind of computing. So Google has this resource Colab, right, that makes you run this thing. So this is the front end, and on the back end you're using their computer. You can see how much RAM you're using from them. You see how much they're giving you 12 gigs of RAM. How many of your computers have 12 gigs of RAM? Not mine. That's a lot of RAM, and you're using a bunch of disk, and you're using GPU. So a GPU, so all these, okay, so how this matrix multiplications, this dot products work is that they're highly optimized. If you were to write your own library that does all these dot products, it would be slow. If you think about like how CPUs work, CPU is just a machine that it's only good at one thing. It only does summations, right? It sums things. That's it. That's all your CPU does. I don't know if any of you have console like PlayStation 4 and Xbox or whatnot. The only reason why they have good graphics, the only reason why they're popular is because they have good GPUs. And why GPUs versus CPU, right? So it turns out that when you're playing games, you're working with graphics. On the back end, what it's really going on, it's a bunch of matrix multiplications. When you're shooting, when you're turning your camera around or whatnot, it's doing a lot of dot products on the back end. Turns out that GPUs are highly optimized for doing a bunch of dot products, doing a bunch of matrix multiplications. So we want to use GPU because GPU will increase the time that your neural network will run 10 times. Yeah, question? Oh, okay, cool. So make sure you run this part, X-train, whatnot. It's downloading the data set. And so we're downloading this data set, and you should have this on your screen. So we're gonna do the numbers again. Why are we still doing the numbers? Because the numbers are the easiest data set to work with. They're really easy. It's really easy. It's like pretty much you can throw any simple model, and pretty much the simplest of the models will throw at least 90% accuracy or 80% accuracy. So that's why I decided to work always with the numbers at the beginning. So okay.
Is it okay that we have different numbers than you?
That's totally fine because it's random.
Okay.
Yeah, I have a random function here. Yeah. Oh yeah. There's a reason why. Always randomize your data. I'm going to show you how to do that too, because the way you present your data sometimes matters. So every time you run your model, you want to show it. You want to shuffle your data. It's good practice to shuffle your data. So okay, so the first thing is that we're gonna create. Okay, so we're gonna use something called a data loader. Okay, let me explain what a data loader is. So a data loader. So a lot of time. So here we have a 12 gigabytes of RAM. Okay, but your normal computer doesn't have that, and usually your computer has like 4 gigs of RAM. Some computers have 2 gigs of RAM, right? So, but you have a bunch of, what you have mainly is hard drive, right? Your hard drive, you might have a terabyte, you might have a bunch of hard drive, right? So when you load things on your code, when you load things here, like these numbers, you're loading them in your code. You're pulling things from your hard drive to memory. So you have a bunch of hard drive, but you don't have much memory, right? So what you want to do is you want to use a data loader. So what a data loader does is that it's not gonna load all the data, all the images that you have at once. It's not gonna do that. It's just gonna point, have a sort of like, it's gonna point to your directory, and it's gonna pull out data chunk by chunk. That's good because you're not gonna kill your RAM. So you're not going to put a lot of stress in your memory, and also you're never going to use all the data at once. You're always going to use like data chunks by chunks. So it's a good idea to always use a data loader. So I'm going to show you how to do data loader. First of all, let's get the data set. So we're going to do train data set equals. So here, so I already loaded the data from next train. So I'm just gonna, so here, if you happen to have data as a NumPy file, you're gonna have to do this tensor dataset. And tensor dataset, let's see what it takes. It takes tensors. Okay, cool. So what you're gonna do is you're gonna call torch point from NumPy. You're gonna do x train, comma, and you're gonna do torch from NumPy train. Okay. And one more thing is that make sure you're on the parentheses right here. You're gonna do dot, and you're gonna do float, and then here you're gonna do long. Why are we doing this? It's because Pytorch actually likes so floats and longs and integers and things. They are types of numbers. So when I was making this tutorial, I came across that it doesn't like certain types of numbers. So it works when you do dot float and here dot long. Okay. So make sure your code is exactly like this. Now, I'm just gonna do the test set as well. So test data set equals, you can actually copy paste the one from here. And then you have to change this one. So you're gonna have to change this one by test and X test and Y test. Okay, make sure that runs. Cool. So everybody positive here. Make sure you have that running. So make sure it doesn't have any errors here. Okay. So we created a data set. So a training data set and a test data set. What else? Let's create a data loader, right? Because that's what we're talking about. We're talking about data loaders. So the data loader, what you're gonna do is you're gonna do train data loader. That's gonna be the variable. And you're gonna do data loader. You're gonna call it the data loader. Also, all these things right here, we imported them. I didn't explain that, but Torch has some libraries called utils, and it has and .data, which is specifically for data. So we're going to be using dataset, data loader, and tensor dataset.
I have a quick question.
Yes.
I had an error running the last code. It said,
Which one? This one?
yes.
Okay.
It said,
make sure you have the exact same thing. The parentheses or whatnot. Make sure, for example, one quick way to check that your parentheses are doing well is that, for example, look at that I'm clicking right here. It's highlighting this parenthesis and it's highlighting that parenthesis.
okay, let me check.
Yeah, same thing here. So it's highlighting that one. That means that parenthesis is being closed. A lot of your errors is going to be when you have errors in your parentheses. Check your parentheses. For example, this float should end its parentheses right there. X string should end its parentheses right there. Same thing for this one. Make sure that's the number one. That's one of the main errors you might get. Parentheses, you know. I usually get a lot of errors for parentheses. Like half of the time I'm coding, I would actually get errors there. So yeah.
Yeah, no, all of mine are right. So I don't know.
Can you run that again?
Yeah.
X train, Y train. This one displayed for you, right?
Yeah, that one was fine.
Okay, so one thing that you can do, you can go to the solutions, and you can copy paste this part.
Okay.
Yeah. Try to copy paste it. If you so yeah, for everybody, if you get an error, go to the solutions. We're doing exactly the same thing as the solutions. Let me not show you much, but yeah. So make sure that runs. Okay. Cool. So let me recap again. So okay, let's create a data loader. So I have train data loader equals data loader. Now, what does data loader take, right? So you guys already saw that. So here it tells you what is it taking. So it takes data set, batch size, whether you want to shuffle it, sampler, and all these things right here. Number of workers. We're gonna use some of them, not all of them. First one is that we're going to pass the data set is gonna be the trained data set. Then batch size, we're gonna do 4. So what that means is that every single time I'm gonna call that data loader, it's just gonna give me 4 images at a time. That's what it means, batch size. Why do you want to have a batch size, right? Reason why is because a lot of times, say that you're, I don't know, say that later on you're working at Amazon, you're working at Google, or you're working at Facebook, you're working with big data, or you're working with, I don't know, you might be doing your PhD later on and you're working with DNA data. From my experience, I'm working with DNA. So the one thing I can tell you is that just 2 samples from 2 people, like it's a lot of memory, right? And so far we've been doing gradient descent or whatnot with all the data. So we loaded all the data and we did gradient descent with all the data. But realistically, you're never gonna do that. You're always gonna do gradient descent with small batches of the data. So you're gonna get a little batch of data, like say 4 images or four samples of your data. You're gonna run gradient descent of that. Then you're gonna pick a different batch, and then you're gonna run the gradient descent with that. That's how you actually do it. You're never gonna do with your whole bunch of data, because you're gonna kill your computer if you do that. With the MINS data set or the data sets that we've been working, all those toy data sets that we've been working, doing gradient descent with all your data, it was totally fine. It was fine because it was a small data set. But yeah, so make sure you always choose a batch size. I usually choose a batch size of 32 or 16. Here we're using 4, just to show how it works. But yeah, always choose a batch size. I would choose 16 or 32. That works. So batch size. Okay, so you want to shuffle it. Shuffle equals true. And then, oh yeah, non-workers equals 4. Okay, this thing. So what it means by number of workers is that, well, you might have a bunch of CPU, and your CPU, it's pretty much how it works is that you want to access 4 elements at a time. So you're gonna do that in parallel. You don't have to code at any you just have to tell your code that, hey, I wanna split this job in 4 by 4 different cores, because your computer has multiple cores, so you pretty much want to split the work. If you have that many cores, might as well use them, right? So yeah, so here specify number of workers for. So this is the train data loader. Let me copy paste that, and I'm gonna create a test data loader. So I'm gonna change the name, test data loader. What it's gonna take in is test dataset, batch size 4, and shuffle. It's gonna be false. Reason why? It's because here you're testing your data. Usually you want to split your data with training and testing. Because your model might work really well with the training data that it's in a way learning from, but it should generalize with testing data, with data that it has never seen before. And we're not shuffling it because it's not needed. We're not using that for training. That's the only reason we're not shuffling here. Okay, so make sure you have that. And yeah, so everybody got that one running?
Yeah.
Okay, so let me show you how it works. Okay, so now we're gonna build a little here. Well, we're gonna do an iterator. So I'm gonna call that data iter equals I'm just gonna do iter and then train data loader. Okay, so what that's gonna do, it's that I'm gonna create an iterator. What is an iterator? So an iterator is gonna, by its meaning, it's gonna iterate through your data. It's gonna go through your data. And remember that your data loader is taking 4 at a time, right? So what if let's extract some data from there. How are we gonna do that? I'm just gonna do images, comma, labels equals data iter next. So data iter dot next. Make sure you run this cell. Data iter dot next. What that's gonna do, it's just gonna say, hey, just give me the next amount of data, and that's gonna be stored in images, and the labels are gonna be stored in labels. So when you run that, you're gonna get exactly. So let's do images dot shape. You're gonna get exactly 4 images, and each of the images is 28 times 28, right? And you only have 1 channel. Here you only have 1 channel because your image is RGB. No, your image is black and white. But if your image is RGB, I mean, it has color, Usually color is described by red, green, and blue. So if you have a color image, this number should be 3, shouldn't be 1. But that's totally fine because right now we're working with black and white data. So it shows you 4. And labels, let's see the labels. Labels should be 9, 6, 0, and 9. That means that's the labels of the data. Yep. Now, so everybody got here without errors.
Yeah, I got done.
Okay.
Yes.
Cool. Okay. So let's run this code right here, im show. I'm not gonna really describe much of what this im show is doing, but what it does, I'm just gonna tell you what it does. It's just gonna show data. This is just a function that's gonna help us later on. Okay, so let's see some of this data. So I'm just gonna create a grid in grid. Oops. I'm gonna do torch vision dot utils dot make grid. And what I'm gonna pass right here is my images. Make sure that runs. I wonder why it's taking forever for me. Is it taking forever for you guys too, or no?
No.
Pretty quick.
No, it's pretty quick for me.
Okay, so it's my network. Usually when that happens, if that happens to you, just copy paste whatever you have there, create a new cell, click a stop on that cell, delete that cell, and then work in a new cell. And now that's gonna work. Yeah.
Oh, sorry. For the thing we did earlier with labels, I got different numbers, but is that okay?
That's fine. Remember, we're shuffling it.
Okay, so it's just random. Okay, cool.
We're shuffling it. Yeah. We're shuffling it. If you get different numbers, just for this class or just for this this one class, that's fine. That means you're doing things the right way. If you get the same numbers, that's a little odd. But yeah. So let's plot that. Let's plot those. So I'm just gonna do im show in grid, and then I'm just gonna do. Let me see. One channel equals false. Boom. We see the numbers. So you just got the numbers 9, 6, and 0, 9, which are the same numbers from the labels. You just put them together. There's a reason why we're doing this, because we're gonna be visualizing these numbers a lot later on. Make sure you have that. You guys have that?
Yeah.
Cool.
Yep.
Yes.
Okay, cool. Okay, so here we're gonna do the, well, this is the model. This is the neural network. So we have the class neural. We're specifying that that's a Pytorch model. Then on the self, we're calling super. I don't know why this one is with a weird. Wait a minute. Make sure you put this right here. Okay, there we go. So it cares about the indentation. If you don't have the right indentation, it's gonna have an error. So the only way to make sure is that always put the next block of data next to the one before, and press enter. That should be fine. And everything you write should be on this line right here. Okay, cool. Okay, so in it, okay, so for logistic regression, what we had was just features. How many features does the data have? It's 28 times 28, right? How much is 28 times 28? It's 784. Okay, and then how many classes do we have? It's 10 classes. Okay, so we have 10 classes. Actually, no, outputs. Called outputs. So you have 10 outputs and 784 features, right? And how you do it is that, well, first of all, you're gonna do self Since the data is 28 times 28, you want to flatten it. So I'm just going to create self.flatten equals torch.nn.flatten. So that flatten, all that flatten is going to do is just going to flatten your data. Okay. Then, so it's going to turn it into a vector. So because pretty much your data, it's 28 times 28. That's a matrix. That's not a vector. So flatten, what it does is just going to turn that into a vector. Okay. So the next one would be linear. Linear torch.nn, and would be linear, right? And that will do is you have your in features equals features. Make sure this is spelled the right way. And okay, so out features would be outputs. Okay. And here, what you have here, let me delete all this block right here. So, okay, so here, what you're gonna do is just x equals Latin inputs. So on forward, remember we had forward and we have backward. So on init, you're only gonna, so let me explain a little bit what it does. So in init, you're pretty much specifying the things you're gonna use. So you're specifying the things you are going to use for your model. And here you're using them on the forward. So here I'm just gonna create x, variable x, and x, I'm gonna pass some inputs and I'm gonna flatten my inputs. Then I'm gonna pass my inputs to my linear function. So I'm gonna pass that x to here, and it's gonna go, and so x is gonna be equal to linear x. Okay, and that's it. So that right there is logistic regression. Don't worry about the sigmoid for now. That's because it doesn't really matter in Pytorch, or it doesn't matter with the loss function that we're gonna use. But this right here is just logistic regression, right? So everybody has this. Make sure you have this.
Yes.
Yep.
So that's logistic regression, right? But then we mentioned that we want to have a deep network. So how do we go from logistic regression to a neural network? So pretty simple. Let's create a hidden layer. So let's do hidden. Let's call that H1. H1 equals how many? Usually I do 128. Okay. 128. Okay. So on linear, I'm gonna rename this one. I'm gonna rename this linear 1. Just this part, not this one. Just this one, linear 1. Okay. So see how, like, check this is how this is gonna go. So I'm gonna flatten my data. I'm gonna pass it here. The input or the input features is gonna be 784, but my out features on this one is gonna be H1, which is 128. So pretty much I turn my 784 dimensional data, and I do a dot product. I do logistic regression. I do linear regression pretty much, and I turn it into a 128. That is gonna, so that is pretty much, suppose that we're predicting 128 outputs. We're not predicting 128 outputs, but suppose we are. That's what we're doing here. But then those outputs of that, we're gonna pass it to another linear function. Linear, let's call that linear 2. And I'm gonna do the same thing. Torch and then linear. Now the in features. The in features is gonna be now H1, 128, because we're passing now we're not receiving the numbers straight. We're receiving a transformation of them, which has 128 features. And now my outputs, it's gonna be, well, no, this one should be out features equals outputs. Okay, so out features equals outputs. So now my input is gonna be 128 and my output on the second. So pretty much this is one logistic regression or linear regression, however you want to do it. Remember, linear regression and logistic regression are the same thing. Logistic regression is just a linear regression with an activation function. In this case, it was the sigmoid function, the one that tells you 0 or 1. That's what it was, right? Here, we're passing this linear regression, and then later when we're going to pass another linear regression. That's all that neural networks are. So make sure you have that. Now, here we're defining things. Let's use them. So let's go to forward. So forward, remember I renamed this linear 1. So here I'm going to rename that one linear 1. So I'm going to flatten my inputs into x. That x is going to go to linear. Then I'm going to pass an activation function. But this activation function, it's not going to be the sigmoid. So let me show you why I'm not going to use the sigmoid and why you should not use sigmoids anymore. So sigmoid is a good example to show you guys to start learning, but because it's really easy to see, okay, the sigmoid only has, let me go to sigmoid, right? The sigmoid only has 2 values, 0 or 1, and everything in the middle, right? Pretty much you can think about it like a neuron or so. The problem with sigmoid is that if you get the derivative of the sigmoid function, your derivative looks like this. Looks like this red graph right here. The problem with that is that, say that your number is right here at this point. Your grading is close to 0, right? Or say you're here. So the problem is that if you have a bunch of you're stacking layers, so each of those linear that we call, all those linear transformations, those are layers. So for each of the layers, each of them has error. And if say that you're here, your derivative is really low, and that derivative is going to be used to update your weights. But if your derivative is low, your weights are going to be updated by a really small value, or are not going to be updated at all. That's the problem. That problem is called the vanishing gradient. That's on the book too. That should be in chapter 4 or so. So what's used a lot is something called ReLU. ReLU. This boy right here. Not that one. This one. Okay, this one. That's ReLU. So ReLU, there's a bunch of papers that show that ReLU just works. It's non-linear because at this point is not. So if this would be a line like that, it would be linear, but it's not linear because this function is 0 before 0, but then later it's just x, right? It's just a linear function. So this whole thing is non-linear, and there's a lot of papers, there's a lot of studies that show that this function works better, and it actually converges faster. So you're gonna get your gradient, you're gonna get the right gradient, and you're gonna get the optimal. You're gonna get to the optimal weights in less time than if you were to use the sigmoid function, and that's because this one doesn't have the problem of vanishing derivatives. If you take the derivative of this, the derivative of this is just 1, because the derivative of x is just 1, right? And the derivative of this one is just 0. So your derivative would just be 0 or 1. And that's better because if you're at this end right here, your derivative will still be 1. So you're going to still be updating values. If your derivative is 0, just in this case is fine because some neurons are going to be shut off. But that's totally fine because you might have a really deep network and you might have a bunch of neurons, and idealistically not all of them are going to work. Only few of them are going to get something meaningful, not all of them. Anyways, so here what I'm going to do, I'm going to have linear 1. I'm going to call torch.nn. No, actually torch.relu, not nn. Yeah. So I'm gonna pass that one to rel. And then here, I'm gonna do torch dot, no, not torch. I'm gonna do linear 2. Okay, and I'm just gonna return that. Everybody has this?
Yes.
Cool, so make sure this one runs. Oh, get an error. What's going on here? Oh, I had 2 equals right here. I don't know if you guys noticed. Okay, let's see. Okay, that should work. Okay, if you were able to run this cell without errors, you should be fine. Let me know if you have an error. Okay, let's see. Let's create a model. So I'm just gonna do model equals neural, and then hey, here it tells you how to use it, right? That's a nice thing. So whenever the only reason why I tell you to put this torch and then model and whatnot here is because once you create your model, it has all this documentation for you. So it tells you how to use it. So in case you get lost, right? So features equals 784. H1 will be equal to 128, and outputs will be equal to 10. Okay, make sure this runs. Did it run for everybody?
Yeah.
Okay, so if you did the GPU thing, if not, please go back and do the runtime, change runtime to GPU, and try to run every single thing with it until now, because we're gonna use that now. So model.CUDA. I'm gonna do this right here. Okay. Model.CUDA. So what that means is that I'm telling my model is to be like, hey, you know what? I want you to be a CUDA model now. So that worked. So it tells me the layers that I have here for like multiple GPUs. Anyways, okay, so let's summarize the model. So here I'm importing this thing. So make sure you'll have this thing here. So let's do this summary. I'm gonna put my model here, and I'm gonna put input size equal to 128. Okay. And oh, what happened here? It says flattening is not defined. Did everybody get that?
Yeah, I got the same thing.
Okay, so what does that mean? Flattening is not defined. Huh. Flattening is there a spelling error? X. Huh. Let me see. Flatten. Oh, okay. This is what happened. You have to put self on here, self on that one, self on this one, because this one have self.planen, self.linear 1, self.linear 2. Don't put self on this one. Sorry about that. Let's see if that works. So model CUDA, and it's funny because CUDA did not detect that error. Huh. Okay, that's funny, but this one did. Okay, so you should have this. Make sure you have this.
Got it.
You got this? Okay, cool. So
Yes.
so Torch, there's this tool called Torch Summary. It tells you a summary of your model. So a lot of times, there's a lot of models that you can download, or you can just copy paste from different places that are already built. So one suggestion for you guys to work on your projects: don't rebuild the wheel. Always, if you are thinking of something, always like go ahead and look online if someone has to work with the type of data set that you're working with. And the easiest thing to do is, like, if you're in Kaggle, here's the data set, right? you can click on kernels, and it shows you cat dogs classification, Keras beginner. Keras is a different tool. It's like Pytorch, but it's a bit easier. Actually, Keras is way easier than Pytorch. The only reason we're using Pytorch is because we sort of build into it, right? If you learn to use Keras straight on, well, you don't have to learn about what gradient descent is. You don't have to learn all those things, right? And that makes a difference if you want to explain your model. Say that you're in a conference or something like that, or say that, I don't know, you have a job interview, right? If you only learn Keras, because a lot of people just learn Keras. Keras is, I actually encourage you to use Keras in your project, but Keras, you know, it makes things really easy for you. So it doesn't really make you think how these things are working, right? But anyways, you will see people use these models, right? Say that you find a Pytorch model that's advanced, but you want to know how it's working internally. So you're gonna do summary. You're gonna get the model, and you're gonna put some input size, and this right here is gonna give you a description of. It's gonna give you a description of the whole model. So here it tells you the output shape is 784. It tells you linear 2, 128, linear 3. That means that the model is gonna throw a 10-dimensional vector. In this case, we want that because we want 1, 0, 0, 0, 1, 0, 0, whatnot, right? And the shape is 784, which is the size of your, in this case, your image, right? The image is 28 times 28, and you're gonna flatten that to that. So this works. Here it tells you how many parameters you're fitting. It tells you that in this case it's 101 thousand parameters. So a summary is using summary is a good way to summarize your model, to see how the data is flowing there. So yeah, any questions so far?
So I get an arrow like for the new one. So basically, the arrow they said the neural object has no attribute to flatten.
Let me see. So do you have this? Did this one run fine?
Yes, they all runs fine.
Okay. Do you have input size, and then you put that dot right there? Do you put this thing right here?
Yes, I do.
Yeah, let me see. Best thing to do again, it's to I hate to do this, but yeah, copy paste this thing right here. Yeah, just copy paste it, and then yeah, just copy paste it. Oh, here, this model the one that I built is a bit deeper. It actually has 1, 2, 3, 4 layers. It's deeper. We're gonna use that later, but for now, let's just stick with 2 hidden layers, or 1 hidden layer. This is the 1 hidden layer. So yeah, make sure. Yeah, so just copy paste that. If you get an error, it's probably because something here is wrong. Yeah.
Okay, thank you.
Make sure, yeah. So make sure you copy paste this, or take a screenshot and like try to see where the error is at. But yeah, make sure this one runs, because if this one doesn't run, your whole thing would not run. And this is like the first pass, like the first thing that you should be running.
Okay, our copy paste is fixed.
It's fixed?
Yeah.
Okay, cool. Awesome. Okay, so you should be getting the summary here. Okay. So here, click. Okay, so we're gonna be using a tool called TensorBoard. So TensorBoard is this tool that allows you to pretty much monitor. Okay, so one thing that's different from last class is, remember last class, on the last classes we were building a list called cost. So we were keeping track of the cost functions and how good your model was, or if your model was actually learning or not. We kept track of that, but we're not doing that anymore. We're leaving that up to this tool called TensorBoard. So make sure you run this board right here, TensorBoard. Okay. So did this run for everybody?
Yeah.
Cool. Okay. So what I'm gonna do here is that I'm gonna import this thing right here. It's called from TensorBoard. I'm gonna import summary writer. So we're gonna create a writer. So what is a writer? a writer is pretty much just this one function that's gonna be the bridge between you and TensorBoard. So with writer, you're gonna be writing to TensorBoard. So you're gonna be telling TensorBoard things about your model. So I'm just gonna be summary writer. By default, things are stored in run. What I'm gonna do runs. Let's create a new model. In this case, let's call it, I don't know, mnest experiment. mnest experiment, and make sure you run that. That should run. Now I'm gonna do writer dot. And there's a bunch of things you can add. You can add audio. You can add figures. You can add graphs. You can add a bunch of stuff. So for now, what I'm gonna add is an image. So add image. And what image am I gonna add? So let's put it a name. I'm just gonna do four digits. Call it 4 digits. And then the next thing so that's a tag. The next thing is gonna be the image tensor. So I'm just gonna pass the grid. So we created the grid before, right? Grid. So I'm just gonna pass the grid. Next, I'm gonna pass some things. I'm gonna pass writer dot add. I'm gonna add a graph. So I'm gonna add graph, and then I'm gonna put model. I'm gonna do images, but images, I'm gonna turn the images to CUDA. And then writer, I'm just gonna do writer dot close. That should run smoothly. Did everybody get that?
Yeah, I got it.
Cool. Okay, so let's run the next one. So let's run this one. Let's run TensorBoard. Okay, so everybody here? Everybody see TensorBoard?
Yeah, I see it.
Yeah, got it.
So you have 2 things. So the first one that we added was 4 digits. So we just add to the writer. We said add image. We added 4 digits. We added the grid in grid. That's the same grid that we created before. And here we're able to look at it. We're able to make it smaller or whatnot. Then we added a graph. What this graph did is just we added the model and we put that into graph. So let's look into here. Can we take a look at the graph? Oh, there it is. It's like really small. Can we zoom in? I don't think we can zoom in. Let me see. It used to let me zoom in. At least right now it's not letting me. But does it let you zoom in to you guys? Fit the screen. There we go.
Yeah.
Okay, yeah, actually now, yeah. So here it tells you a little description of this thing. So it tells you that the input is gonna be 4. In this case, I just passed 4 images, which is the grid. 4 images times 1, which is the amount of channels. 28 times 28, which is the size of it. It's just gonna go to our model neural. And then the output is gonna be 4, which is the 4 images again, 4 times 10. And it just tells you a little description of the model. So images, graphs. Cool. Now, here I have this one thing right here. Let me describe it briefly. Here what I'm doing, I'm passing the model, and I'm gonna put some images. Then I'm gonna pass the softmax function. So what is softmax? Let's Google it. So softmax, and then let's look at the equation here. Okay, so softmax. So softmax, what it does, it pretty much calculates the exponent of each of your outputs, and after it does that, it normalizes it. So pretty much by normalization, say that you have a bunch of numbers, right? Let's make the math here. So let's go to Desmos. Desmos always works. Say that your model outputs 20, 10, and 3. Okay. So what it will do, it's just gonna do this. So let's say that you want to look at this one, right? It's just gonna calculate the exponent of that one, and it's gonna divide it by this one, by that one, and by that one. So what that means is that it's gonna be 0.99 certain that is that class, that is that one. But if we're to change that one, let's say let's look at this other one, then it's gonna be 0.004 certain that is the other one. You guys see that? That's what softmax does. So softmax, all that it's gonna do, it's just gonna put everything to an exponent, and it's gonna normalize it. So here's a good example. So you have 2, 1, 1, 2, 1.1, right? This is the result from the linear function. It's gonna go to the softmax, and the softmax is gonna throw a probability. It's gonna be 0.7, 0.2, 0.1. So for example, in the case of numbers, right? Your thing might be, okay, I'm 0.9 certain that this number is a 1, but I'm 0.1 certain that this number is also a 9. Right? That's pretty much what it's doing. Okay, so we're passing that to softmax, and then we just get the maximum number with this one, and that's gonna be the probability and the prediction. Then again, make sure that after class at home, you actually look into this. You're more than welcome to reuse this for your project, because this is actually really cool. This one is actually like a cool function. I actually borrowed that from Pytorch. So let me see, what else do we have? So we added the, okay, so then plot classes. So make sure you run this one, right? Make sure you run that cell. Make sure you run this one cell too. So what that one does, this one calls that function to get the probabilities and predictions. And this one, all that it does, it plots them. It's gonna make a really nice plot. Let me show you how it does it. So here, make sure you run this cell. Make sure you run that cell. So here I'm gonna create this fic equals plot classes spreads. I'm gonna pass my model. I'm gonna pass my images. I'm gonna turn my images to CUDA. I'm gonna pass my labels, and I'm gonna turn them to CUDA as well. Okay, make sure you have that. Let's run that. Boom. So this is the first predictions that our model is doing. It looks at this and it's like, oh, it's a 5, but I'm only 12% certain. It looks at this one, it says, oh, I'm a 5, but I'm only 11% certain, right? So these are all ground predictions, because we just started the model. We have not trained it. Do you guys see this?
Yeah.
Okay, so we're gonna go after training. We're gonna go back to this, and we're gonna click off this again, and this should all be green. I made this so it's green if it's the right prediction. Okay, so then again, we're not coding this from scratch. I actually didn't code it myself. I borrowed it from online, from the internet. I was like, okay, let's see something that does this, right? So yeah, cool. So here, this is the fit function. This is the same fit function that we did before, with few differences. Let me put it here. So here we're gonna have data loader, and the data loader is gonna go to this data, right? Remember, data loader, every time you call data loader, it's gonna give you 4, because we specified that it's gonna give you 4, right? So it's gonna give you four images every single time. Those images are gonna be 2 inputs and the labels. And then the device thing right here, let me explain that in a bit. But this device right here, what it is pretty much just where you're gonna specify the device. So you want to train it on CPU, you want to train it on GPU. We're gonna train it on GPU, so that we're gonna specify the device to be GPU. Here, remember last time we did optimizer.serialgrad, because we wanted to clean out the gradients every single time we run it, because Pytorch likes to store them and stacking them, and we don't want that. We don't need that. So we do optimize serialgrad. The outputs is just, you have your model and you pass your inputs, and that's your outputs. Then J is your loss function. So you want to calculate the loss between your outputs and your labels. and that's gonna be J, which is your loss. And then you go backward, which calculates the derivatives for you. And what a step does is just your optimizer. Remember, we're talking about momentum and whatnot. What that's gonna do is just gonna take your gradients and it's gonna update your weights. Then we wanna keep track of our costs. I'm just gonna keep adding. So J.add, J is your cost. So I'm just gonna get that cost and I'm gonna keep adding that. I'm gonna keep adding that right here. Here, remember we did our writer, right? Writer, which is something that talks to TensorFlow. So what I'm gonna do here, I'm gonna do writer, add scalar, and I'm gonna pass my cost. So I'm gonna do my running cost, and I put print every. So pretty much, I'm just gonna say for every 100 times. So every 100 gradient descents, I'm gonna write something to TensorBoard. And my predictions, you see these little guys right here. We're also gonna keep putting those to TensorFlow. So I'm gonna add figures to TensorFlow. Writer, add figure. Okay. So make sure well, this is already there, so you don't have to write anything there. So make sure you run it. Make sure you run that function. Okay. So now, this one takes device. So let's calculate device. So device. So sometimes you don't know what you're using. So we're gonna do this. Device equals torch dot device, and then we're gonna do CUDA. Oh, remember to open the open parenthesis. CUDA 0. Is it 0? It is 0. If torch dot CUDA is available, else CPU. Okay, and then print device. Oh, error. What's going on here? Oh, the comma. Okay, there should be no comma right there. There we go. CUDA 0. You guys got that? It should say CUDA right here.
Yep.
Cool. So
Yes.
why is this line of code here? It's because say that you want to run this in your computer. This code will run on your computer, but in your computer, since a lot of your computers don't have GPUs, the device will be CPU. And you want that because you want your code to run everywhere. So this is a good practice. Always, actually, I made you guys write it on the bottom. Always write it on the top. Always write it on the top. Yeah, this is just because for now we're gonna train it. And the only one time that it appears is on the fit function. But then again, always write it on the top of your code, like after you import your libraries. So your code, so every single time you run your code, is gonna be sent either to device. In this case, either sent to GPU or CPU, right? So you guys will use this a lot in your projects if you end up using Pytorch. Okay, so let's do this. So loss will be equal to torch dot nn dot let's use cross entropy loss. There's that. Now optimizer. What optimizer are we going to use? Let's use STG, which is torch dot optim dot what else was this? Oh yeah, SGD. And then let's see what SGD takes as parameters. So SGD takes parameters, learning rate, momentum, and weight decay, and all those things. So the parameters would just be model dot parameters. Make sure you have parentheses right there. Comma. Your learning rate, LR, would be 0.001, and momentum Let's put 0.9 momentum. Okay. Make sure you run this. That should be running fine. Everybody did not get an error.
Yes.
Okay, cool. Now let's call the fit function. So fit. Let's see fit. So fit takes model, data set, loss, optimizer, device. Now it takes a lot of things. So we're gonna pass the model. The data loader. Okay, the data loader. What was the name of the data loader that we had? It was train data loader. Yeah. And then it's gonna pass the loss function. We have our loss. It's gonna pass optimizer. You're gonna pass device, which is our CUDA. Epochs. Okay, epochs is how much time do we want to run it? I usually do 1. And print every. I actually put 1,000. So every single 1,000 steps, you're gonna pass it to TensorBoard. Okay. Make sure you have the exact same code before you run it, because after you run it, I'm not gonna stop this part. It's gonna take like a good minute to run. So make sure you have the exact same thing. So cool. Let's run this. So here, this is running just the batches. Just telling you, okay, cool. And this is the bar that tells you what epoch. So I'm on epoch 0, but I'm only running that once. If I was to run it twice, then it's gonna be ba 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 ba. Like it's gonna be running more times. But here, we're just running a single batch. Well, we're running multiple batches, just 1 epoch. That means we're just going through the data only once. That's what that means. Everybody has this bar, right? Running.
Yeah.
Yes.
Yep.
Yeah, I don't know if it's an error. It says line number was not unique in database.
Ooh, I don't know what that one is.
This history logging moved to new session 63.
Oh no, that's fine. Try to run it again. Yeah, that's fine. That happens a lot. Yeah,
Okay.
that happens a lot. Yeah, it happens to me a lot. Like I hate when it happens. Yeah. Remember that we're not using resources from our computers. We're using resources we're borrowing that from Google. You know, so sometimes Google is gonna lock you out or things like that. That happens. That's really bad. But
Okay. Yeah, I mean, I still have that same green bar. It's just
okay.
that.
But yeah, no worries. That's not really an error. It's just yeah. But okay, so we go to scalars. Here, hey, it shows you our cost, training cost is decreasing. Let's make that a little bigger. Can I make that a little bigger with this one? Oh, this one. There we go. So here we have this no, we don't need to make it bigger. So we have this training cost. Images. So there's so the second writer. Oh wait is that one up here? Okay. So images, what that's gonna do. Here you see, okay, at the beginning, it was at the beginning, okay, it's funny. It's still doing good predictions. But usually how it should go, there's a bad prediction right there. The more right you go, it should be making better predictions. So here you can keep track of like how well the predictions are being done. So for example, on the latest one, it predicted that one as a 2, but it labels 4. But that's fine because nothing is perfect, you know. And we also run it. We also went through the data once. Take that into account too. We only went through the data only once. So usually when you want to leave this running, at least in your case, you guys, for neural networks, you want to leave that. Some people keep them for months. We're not doing months, right? But usually they run it for hours. So usually about 1 hour or so, your model should be plateauing. Or what I mean by plateauing is that you should see this learning rate plateau and not decrease anymore. That's the point in which you should be like, okay, this model converged, right? So yeah. It's funny because this tool is actually kind of new. This did not exist when I started learning about like TensorBoard. I mean TensorFlow. And I barely learned Pytorch like few weeks ago, but it's really good. Like you can keep track of things, how things are going in your model. Okie dokie. And let's rerun this one again. And you should see now it's like 99% accuracy. It's like 99% accurate that this is a 0, right? So now it actually learned that well, this is a 9, this is a 9, this is a 6 or whatnot, right? So everybody got their tensor board working too?
Yep.
Yes.
Yeah, I got it.
Cool. Hey, you guys are experts now. No, but yeah, so you guys should have like, oh, tensor board, to be honest, it's like this is one of those tools that takes a while to master. I just follow some tutorials online just to show you guys how it works. But yeah, like tensor board is just this one tool that it like lets you interact with it, right? All you have to do is just write to it. That's it. Okay. So now let's go to business. Let's go use oh, actually I forgot to do one thing. Let's calculate the accuracy of the model. So accuracy. So run this cell, accuracy. And what I'm gonna do here is I'm just gonna write accuracy, how accurate the model is. So what is shown in TensorBoard is just your training data. Now let's test it with the testing set. So I'm just gonna do test data loader. I'm gonna pass device. Make sure you have that. And when you run that, that's gonna take a good, I would say, 30 seconds to run or so. And it's with testing images is 93% accurate. So that's really good. Did everybody get 93? Did everybody get more?
I got 93.
93.
Okay.
Yeah, 94.
Oh shit. Okay, cool. That's good. And it's great because we only went through the data once. We only went through the data once. That's it, and we get 92% accuracy. That's why I'm saying that the MNIST is a kind of data set that's really easy to work with, because you're gonna get no matter how trashy your model is, the models are trash. You're still gonna get a good accuracy. Like that's how it works. Okie dokie. So let's go. Okay, everybody, go to your Kaggle account. Make sure you have Kaggle. If you don't have Kaggle, please still follow. But I'm just gonna show you how to do it. So everybody in Kaggle, go to kaggle.com. Yeah. Everybody in your Kaggle.
Yes.
Yeah.
So click on your little picture, if you have a picture, and go to my account. Okay. Now, here, what I want you to do is click on create new API token. And that's gonna download a file to your computer. So I'm not clicking on it because I already have it. It's gonna be called kaggle.json. Okay, make sure you download that.
Got it.
You got it? Okay, let me see. Everybody, write in the group chat if you got it.
Yeah.
Yeah, I got it.
You got it? Cool. Okay, that Kaggle.json. So that Kaggle.json is pretty much like an authentication of that your download that pretty much is like a key. Think about it like a key. So you're pretty much telling Kaggle, hey, I'm downloading this, but we have to set Kaggle to your notebook. So we're gonna run this. Oh yeah. So click on this guy right here, on this little folder. I don't know. You can see this.
Yes.
And I want you to go to downloads, to your downloads, and I'm running a Mac, but in your Windows you can go to the directory that you downloaded the file, and I want you to drag it and put it on these files right here. It should be right here, kaggle.json. You guys should have that one. Okay, so did everybody has this? Everybody has this Kaggle.json right there?
Yeah.
Cool. Okay, so run this line of code right here. So what this is gonna do, it's gonna install Kaggle. It's gonna do some pip install. If you're on your computer, you're also gonna run this pip install, kind of like when we did conda install. This is gonna install to Colab because Colab doesn't have. Colab has a bunch of libraries, but doesn't have all of them. So we're gonna install Kaggle. This is gonna make a new directory called Kaggle. Then once you have this, make sure you have this. Run this one. So what this is gonna do is just gonna copy your Kaggle.json into that folder, Kaggle. This change mod 600. What this is gonna get some privileges. So it's gonna change the mode. So it's gonna make this readable because Kaggle.json was downloaded from the internet. When things are downloaded from the internet, your computer is not allowed to at least not everybody in the system is allowed to read it. So we're letting that to be read, right? Here, we're calling the function Kaggle, and it's gonna download the docs and cat dataset. So here, if you're working with your own dataset from your project, here this is where you're gonna put the link of the dataset. For example, here, I was on cats and dogs. I'm just gonna copy. Well, let me go to data. Oh, I don't hate this little thing right here from. Let me see. Well, I'm just gonna copy the link. I'm just gonna copy the last two parts, which is the name of who uploaded it and the name of the data set. And that's gonna be a zip file. And the zip file, you're gonna unzip it. So let's run that, the whole thing. So let's see. Now it's downloading. Did everybody get this little bar right here?
Yeah.
Cool. Okay, cool. It's downloading it. It's gonna take like good 30 seconds. Now click on this little guy right here and press the X. What that's gonna do, it's just gonna clean out the whole message that it sends you because it's huge. Okay, so you don't have to do that part, but it's just you know the whole printed out message in your notebook. Okay, so now click on refresh right here, and you're gonna see new folders. So these new folders, this dataset doc. So this is gonna contain the dataset. So how the dataset looks like? It's you have a test set and you have a training set, and in the training set you have cats and dogs. So you have cats. Let's not open that one right here, but you have cats and dogs, and for testing set, you have the same thing, cats and dogs. Okay, so yeah, so this is how you load the data set from Kaggle into your notebook. You're not gonna see many tutorials online to explain this, but I did my whole research, and this is like the best way to do it. So make sure, yeah, so you can borrow this code. So cool. Okay, so when you download images, you're gonna see a few things. So let's import this. Let's import Pytorch vision dot transforms, and I'm gonna ask transform. On ask transforms. Okay. So a lot of the data that you have, a lot of the images, they have different sizes. And so an image might be more rectangular, an image might be a square, right? So you want to transform the data. So here we're going to import. So the nice thing about Pytorch is that Pytorch has this thing called Torch Vision transforms that lets you transform the data. So I'm just gonna do data. I'm just gonna create a data transformer. So data transform equals transform. Transforms. There we go. Transforms. And let's see what it has inside. Doesn't tell me anything. Huh. Okay. Okay. So here, let's do it that way. I'm gonna open a list. So what transforms? Oh no. It was transforms dot compose. My bad. It was dot compose, and compose is with this big C. Okay, let me see. Compose. Let's run this one for now. Requires an argument. Transforms dot compose. Okay, so here what I'm gonna do here. I'm gonna pass a list. Yeah, so it wants an input. So I'm gonna pass a bunch of transforms. So I'm gonna pass the first one. It's gonna be transform dot resize, and I'm gonna resize it to 64 times 64. So all the images I'm gonna resize them to 64 times 64. So transforms. No, make sure it's transforms, not transform. Transforms. Then comma. I'm gonna do transforms dot. I'm gonna do grayscale. So I'm gonna turn the images to grayscale, and then I'm gonna turn it into a tensor. So transforms. Remember, tensors are the type of data that Pytorch works with. Close this. Okay, make sure you have this. If not, also go to the solutions. This one is in its own cell, so make sure you can copy that from there too. Make sure you have this one. Make sure it runs too. Did everybody has this running?
Yeah.
Cool. Now let's do this. So I'm gonna do a train dataset. It's gonna be equal to torch datasets. No, it's torch vision dot datasets dot image folder. And I'm gonna here, this is really important. We might not get to compile it. We have like, what time does the class end? 5:45, right?
Yes.
We have
Yes.
10 minutes. Okay. So we might not get to train the neural network with this data, but at least I'm showing you how to load the data, because that's the thing. Once you have your data in training in trained data set in your data loaders, what does fit take as an input? Where's fit? Where was fit? Oh, fit is down here. Fit, what does it take? It takes a data loader. So all you need is just to set up your data loader. That's all you need to do. But yeah, so I'm going to show you how to get your data loader. So image folder. So the first argument that it takes, it's the directory. Where's the data stored? So in this case, we're going to go to dataset, because that's the folder that it created when we uncompress the data from Kaggle. And then we're just going to do, let's see. So we have training set and testing set. So here's going to be training set. Okay. Then we do transform. Oh, we're going to transform the data. And my transform is going to be, well, data transform. Oh, there we go. Make sure you have that. So this first element is going to be that one, comma, transform equals data transform, the one that we created before. Cool. Now we're going to create the data loader. So train data loader is going to be equal to data loader. The argument that's going to take is train dataset. It's going to take the dataset. The batch size is going to be different. Batch size, we're going to pass, I don't know, let's pass 32. Let's pass 32. Shuffle equals true. And non-workers equals 4. Okay, make sure that runs. Oh no, I'm getting that thing again. Is it an error? Everybody has this running?
Yeah.
Okay, it's my internet. Let me kill that one. Let me write it again here. Okay, there we go. Cool. Okay, so let's create the data eater equals eater and train loader. Also, we can create a data loader also for the testing set for the testing. We don't have time to do that, but it's also on the solutions. Here we created this is the same thing. Instead of training set, you're gonna pass the testing set. Okay, but just take into account that. So I'm just gonna do data eater. I'm gonna do images labels equals data eater dot next. Okay, so cool. I'm gonna do im show and I'm just gonna pass this. I'm gonna do torch vision dot utils dot make grid, and I'm gonna do images. Then I'm gonna do one channel equals false, and then I'm also gonna print the labels. Print labels. Okay, this if you get it right, you don't get it right, doesn't really matter, because we're not gonna use this later. But this is just to visualize the data. Usually, when you load some data, you want to be able to visualize it just to double check that you loaded the right data. You know, so here we're gonna print that, and hey, we see some dogs, we see some cats. See, like, you know, so we did, yeah. So we turned into grayscale. So like you're gonna see them grayscale. So this is a cat. It's kind of flipped. But yeah, did everybody get? Oh, I mentioned that you don't need to see this, but yeah, you don't need to do this. But this part right here, yeah. So this just shows you this is just gonna show you the cats and dogs. So let's proceed to create our model. Okay. So I'm gonna call this one CD model equals neural. So let's zoom out a little bit. What does neural take? So features, right? So features equals, okay, so to what size do we resize the images? To 64 times 64. So what we're gonna do here is gonna be 64 times 64. Then H1, the hidden layer. 128 is too little. Let's do 1024. Actually, that's a lot. No, that's good. That's good. So then outputs is gonna be 10. Actually, let me think about this part. 60. How much is 60 times 60? That's 30. That's
6. Oh,
36,000, right?
3,600, I believe.
Yeah.
3,600, right? Okay, yeah, that's good. Just to make sure that the later always make sure that the later stage has less features than the one before. So the one before should have more features than the one. Yeah, the one before should have more features than the one after. Because at the end we want to only have 10 features, right? And those 10 features should be the ones that tell you. I know. In this case, we want 2 features. We want the one that tells you this is a cat, this is a dog. Okay. So only 10,024. Maybe that will run. That will work. Maybe that wouldn't. But double check. Summary. Let's do summary. Let's throw CD model. Oh, also, I forgot to do one more thing. CD model to device. There we go. Okay. Now, here I'm just gonna do summary. Input size equals 16464, and this is the summary of the model. So here it tells you that it's how many. Oh, that's a lot of parameters. That's 4 million parameters. Isn't that a lot? That's a lot. That's That's why we have GPUs, because GPU, if you were to run this in your CPU, it would take forever to do. That's why we're using GPUs. Cool. We only have 5 minutes. Let's try to. Okay, let's see a little bit. So let's do fic equals plot classes threads. Let's pass the CD model, images dot CUDA, and labels dot CUDA. Okay, so it predicted it well, huh? That's funny. So a 1, because it's all logs. That's why it's 50% accuracy too. That's not good. So here a 1 is a dog and a 0 is a cat. So here's like, oh, this is a dog, this is a dog, this is a dog, right? Okay, so let's create a new writer. Let's do, this writer is gonna be, well, the one that's gonna, now this is gonna be cat dog. And let's train the model. So let's do loss equals, actually, you can go to the one before if you have luck finding it, but there's a lot of code right here. You can copy paste that one and change a few things. Here it's gonna be CD model, and here it's gonna be CD model. And what else? Let's put at least 5 epochs. Okay, so everybody has this. Make sure you copy pasted it. If you don't, that's fine. Just make sure that, you know, at this point, yeah, don't worry about it. Let's just watch. So here's just gonna train it. Disclaimer alert. This is not gonna be a good model. Reason why? Because we're not going that deep. If you go to the solutions, in the solutions, I actually have a model that's even deeper. The linear, how many linears? I have 4 linears. In our model called a vanilla model that we created, we only had two linears. That means that we only have two layers of neurons. But in the other one, I have 4 layers. The more layers that you have, it's the more complex the more complex patterns your neural network is learning.
I have a real quick question. How many threads are available to us with this collab? Because we're only using numworkers 4, right?
Yeah.
Is there, like, could we change that to 8 or 16 or 32?
Yeah, you can do it. The problem is that you're not using that though. You're only using it to get the data. So each of the threads, it's calling the images from here, and it's just loading them. But it's really not. That's not really the most expensive task that you're doing right now. The most expensive task that you're doing is the GPU thing. Yeah, so you can do it. Yeah, it's just to be honest, it says Python, Google, Computer Engine, Backend GPU. I don't really know how many cores that they have, because I don't use CPU at all. That's the thing.
Okay.
Yeah, but I've used multi-threading before with here just for testing, and yeah, it sort of works. But I'm not sure how much you can use there. But I know the thing is, like, that doesn't really matter. What's gonna be the most time consuming task would be training this thing. In fact, that will take you hours, and we're not training the whole thing right now. But you can go, okay, so after training, you can go back to your tensor board, reload it, go to scalars. Let me see. That did not get updated. That's funny. Let's rerun this. Let's see. There we go. Okay. So let's go click on that one. That one didn't print anything, but the images. Oh, I see why. Okay. Reason why I didn't print anything is because here we did print every 1,000. Let's put print every 10. Okay, that's the reason why. Okay, got it. Do print every 10. That's the reason why I didn't print anything there, because this data set is smaller than the data set from the numbers. So if we do print every 10,000, print every 1,000, whoa, we only have 250, so it's never gonna reach 1,000. So yeah, in this one, just do print every 10. Now, you should look into your thing. Oh, here we go. Here's telling us how much it's learning. Okay. So here it kind of plateau already, so it's not gonna keep learning anymore, unless you throw a smaller learning rate. Here's it's updating. So here's just gonna keep updating. If you go to images, let's see. Let's see images. It's not showing any image yet. Oh, there we go. Here's the doggies and the cats. So 51% accuracy. So okay, it's improving. So now it's 0.70%. So it's improving. So yeah, yeah. Actually, we got to finish everything. So yeah, thank you all. So hopefully this will help you get started on your project. So I would say best thing, just go to Kaggle, go through all the data sets, find one that you like. You know, if it's images, you know, I find actually, let me see, there's it shows you recommendations. For example, you have fruits, you have X-ray images, for example. We could have done this today's class with X-rays as well. This is X-ray images for pneumonia. So there's the ones that have no pneumonia, just pneumonia, right? So you can try play around with those data sets. So yep. So that's, you guys are dismissed. Any questions or anything? Anything? Uh-huh.
For the final project,
Yeah.
is that okay in teams or individual?
You want to work in teams? That's awesome. Yeah. Really, I don't have any guidelines as long as you present something.
Okay, thank you.
Mm-hmm. Yeah. So as long as you present something, and then each of you should be, if it's groups, each of you should be able to tell what part of the project they did, and why, and what do you learn. That's it. Yeah, that's pretty much it. But yeah. All right, guys. So make sure to choose a data set. And yeah, that's pretty much it. Also, if you want to keep learning Pytorch, all of this right here, it's not that I know Pytorch. I just pretty much borrow a lot of it from the tutorials. The tutorials has this thing, deep learning in 60 minutes, and pretty much covers the same thing that we cover in the class. So yeah, so every single thing that this is pretty much a summarized version of the whole Pytorch thing. You know, just in a slowly manner. But yeah, so yeah, so guys, take care. So see you guys next week.
Bye.
Thank you.
Thanks. Bye.
Bye.
Thank you.